Welcome to Awdhesh Academy. We had done 3 video lessons on real numbers. Today it's our 4th one. We are going to discuss about the decimal expansions of real numbers today. Let's first know what is a decimal expansion. A decimal expansion is a result of a division. So let's take a few examples. First of all, for the sake of convenience, we are taking smaller numbers. So let's first divide 5 by 2, and in another case let's divide 5 by 3. Now in this case 2 times 2 is 4, we get the remainder 1. Now we'll add one decimal here and a 0 here. Now 5 times 2 would be 10 and we'll get 0 as a remainder. The rule of the division is you carry on with the division until you get a 0. Now moving on to this case, 1 times 3 is 3 and we get the remainder 2. Now we'll add a decimal here and a 0 here. So 6 times 3 would be 18 and we'll get 2 as a remainder. Now we can add a 0 here. Again 6 times 3 will be 18 and we'll get the remainder 2. So this is a never-ending process. We are getting the remainders 2 at every step and we'll continue getting it. There is no end of this division. So this type of division where the division terminates or we get the remainder 0 is called a terminating decimal. And this type of division where the remainder never gets 0 and keeps on repeating is called a non-terminating repeating or recurring decimal. Now, as you can see, this is possible only in the case of rational numbers. Let's recall, we did the classification of real numbers where real numbers were of two types, that is rational and irrational. Rational numbers were those numbers which can be represented in the form of p by q, where q was not equal to 0. This is nothing but saying that the division of two numbers is possible. That is, this p by q is nothing but, say in this case, the division of 5 by 2 is basically 5 by 2 as a fraction and the decimal value is 2.5. Now, in this particular case, we can write this division as 5 by 3 and the decimal value will be 1.666 and so on. This can be rewritten as 1.6 with a bar on the 6 denoting that this number 6 is recurring or repeating. Now, as we had seen, an irrational number cannot be written in this form, so the division is not possible in case of an irrational number. Irrational numbers are basically non-terminating and non-repeating or non-recurring in nature. Now please note, in case of this division it was repeating, here it is non-repeating. This is the difference between the decimal expansions of rational numbers and irrational numbers. So to sum it up, a rational number has two kinds of decimal expansions, that is a terminating kind or a non-terminating, repeating or recurring type. An irrational number has the decimal expansion with non-terminating and non-repeating type. Now, to further understand the concept of decimal expansion, let's do some more divisions. Say, first we do the division of 35 with 10. So 3 times 10 is 30. We get 5 as the remainder. We add a decimal here and a 0 here. We get 5 times 10, 50, and the remainder is 0. So 35 divided by 10 or 35 by 10 becomes 3.5. Let's take another example. Let's divide say 110 by 25. Now in this case 4 times 25 is 100 and we get 10 as the remainder. Again we add a decimal here and a 0 here. So 4 times 25 is 100 and we get the remainder 0. So 110 by 25 or 110 divided by 25 gives us 4.4. Now let's do another division. Let's divide 10 by 3. Now in this case 3 times 3 is 9 and we get 1 as the remainder. Adding decimal here and a 0 here, we get 3 again and 1 again as a remainder. So this means this will be a non-terminating repeating type of decimal. That is 10 by 3 can be written as 3.3333 or 3.3 bar. Now what do we observe here? That whenever we are dividing with numbers which are of the form 2 raised to the power n and 5 raised to the power n, that is, the prime factorization of these divisors contain only 2's and 5's, in those cases we get terminating decimals. In the case where the divisor was not of this form, the decimal expansion is a non-terminating repeating one. Now let's consider another example. Let's divide 21 by 6. So 3 times 6 is 18. We get 3 as a remainder. We add a decimal here and a 0 here and we get 5 times 6 is 30 and we get the remainder 0. So 21 divided by 6 is equals to 3.5 and it is a terminating decimal. Now you may think that the 6 is not of this form. 6 is basically 2 into 3, but we get a terminating decimal here. Now this happened because 21 and 6 are not co-prime. They have a common factor which is 3. So 21 by 6, if we cancel the factor 3, we get 7 by 2. And since this 7 by 2 has the denominator of the form this, that is why we are getting a terminating decimal here. So this is very important for you to understand that given a fraction, you have to check whether the numerator and the denominator have any factors in common or not. Now we have some complicated theorems explaining this simple concept. The first of all is, let x be a rational number whose decimal expansion terminates, then x can be expressed in the form p by q, where p and q are co-prime and the prime factorization of q is of the form 2 raised per n into 5 raised per n, where n and m are non-negative integers. So this is nothing but the divisions we have seen here, that is, whenever the decimal terminates, like in these two cases, the denominator or the divisor of the division is of the form 2 raised per n and 5 raised per m. Now the converse of this theorem is also true, that is, if we have a rational number whose denominator is of the form 2 raised per n and 5 raised per m, the decimal expansion would be of terminating type. This is what is said in the next theorem. Let x equals p by q be a rational number such that the prime factorization of q is of the form 2 raised per n 5 raised per m, where n and m are non-negative integers, then x has a decimal expansion which terminates. Now, the third theorem is related to the non-terminating repeating decimal type, which says let x equals p by q be a rational number such that the prime factorization of q is not of the form 2 raised per n 5 raised per m, where n and m are non-negative integers, then x has a decimal expansion which is non-terminating repeating or recurring type. So that's all about decimal expansions of real numbers. Hope you got the concept well. Now please take the test at the end of this lesson and revise your concepts once again. Thank you for watching. Good day.